Okay, good morning or good afternoon. So today we're going to be talking about how to graph in your Ti-Nspire calculator. Uh, we want to start off by graphing linear functions. So you all have your calculator, and I know that y'all just at this point been playing around with it, trying to figure it out, trying to figure out the buttons, and that's exactly where you should be. That's exactly what I want you to be doing right now. Keep playing with it. I promise you'll catch on to certain buttons. Keep asking me questions. I really appreciate all your questions that you're asking, but the key is to keep just plugging away at it. It'll click one day. But you got to keep practicing with it. So we are going to kind of today do I like to call it a click with me. So you're going to click when I click. So I think this is going to be a really good thing that I'm doing a flip video in class. That way you can watch what I'm doing and click, really literally click when I click. And if you want to pause it, you can. If you don't want, if you're want to, you're good to go. I mean, keep going. So I think this will be a good thing for you to be able to do, to click when I click on through this flip video. That way you can come back and watch it again if you need to, or if you have any other questions, you can reference this again and again. So if you turn on your Ti-Nspire calculator, this is your window that you see. I know that yours probably doesn't say CAS right here, and that's okay. It's the same calculator. But I wanted you to be able to see a calculator while I'm clicking. So this is your window that you should see. You're going to, normally you go to calculate, but right now we're going to go to graph. So this is your coordinate plane that you have. It's an X and Y axis. It's already labeled for you. It's very nice and pretty. So we're going to start off by graphing in slope-intercept form. So you're going to go to menu, and you're going to go to graph, and you're going to go to function. Now this one right here says f1 of x, which is the same thing as f of x. The calculator does a really good job of organizing all of your functions. You can put up to 99 functions in the calculator at one time. We're not going to do that. Feel free to play around with it if you would like to on your own time, but we're right now just going to put in a couple of functions at a time. So in order to recognize the difference between the two, it has a numerical system that is very helpful. It has a 1 in between the f and the x. So you know that this is the first function. The first function that we're going to put in here is negative 3x plus 2. So you're going to plug in negative 3x plus 2 or minus 3x plus 2. It recognizes both. It's okay. And then you're just going to simply push enter. And there is your linear function. It is graphed for you. It's beautiful. It's blue. If you graph another one, it's going to be a different color. It's very nice. It's very nice and neat, and it's right there for you to be able to see. Now, with this, you can tell that one of our parameters is our y-intercept, and it is at plus 2. And then you can tell that our slope is up 3 and over to the left 1, because it is a negative correlation. It has a negative slope. Because if you read it from left to right, you can tell that the slope is going down. The steepness of the graph is going down from left to right instead of going up. Now, with this, because you put in a function, I want you to also know that you can see the input-output table, because you have to remember that just because you're doing a linear function, it also relates directly to an input-output table. It relates to your XY table. Those are the same thing, so I want you to see that. So go to menu and go to table and go to split screen table. So right here is your XY table. It has all of your inputs, your X values to the left and to the left right here, and then it also has your Y values or your f of x, your rule, if you will. Now you can tell it because it is a linear function, it goes on forever. Okay, so it goes on forever to negative infinity to positive infinity. So this table will go on forever. So we're not going to go and look at all of this, but it's really nice to be able to see your key attributes, which are your slope in your slope-intercept form is your b value, or your y-intercept is that ordered pair is 0, 2. This ordered pair is 1, negative 1, 2, negative 4. Now, all you need is these points in order to graph and plot on a coordinate plane, and then connect the dots, because it is a continuous function, because those are in between each variable, or in between each input and output, there is fractional pieces of those in between. So there's infinitely many dots in between every single input and output. So let's look at another function. I want to go ahead and get rid of this table, because I don't think I can add a function without. So I went to menu, I went to table, and I'm going to remove the table, just so I can see the whole window again. Now I'm going to go to menu, and I'm going to go to actions, and I'm going to delete all, because I want to delete it. Now I'm going to add in another one, so I push menu again, and I'm going to graph a function. Now I'm going to graph the function 1/2 x minus 3. So in order to do that, I have to push control and then the fraction template, 1/2 x minus 3. Okay, now if your graph doesn't look like this, I want you to go back and I want you to rewatch those couple of steps, just so you can see what's happening in the graph. So your starting place is at -3, and you're going to go up 1 and over 2, up 1 over 2. So you're going to have your rise over run in that case. So now we have graphed our linear function. I want to graph another function that is perpendicular to this function and contains the point 0, 5. Now we've done a lot of practice with this on paper, but I want you to visualize what it looks like in the graph. So in order to do that, we have to identify our slope. Our slope at this point is 1/2. So in order for it to be perpendicular, we have to have the complete opposite, or we have to have the opposite sign and the reciprocal of that slope. So the opposite sign and the reciprocal of that is -2. So we're going to have our new function. So we need to go to menu, graph, function. Now you see it has 2 because it's our second function in here. And we're going to plot our second function, which is -2, -2x. And then it also has to include the point 0, 5. When it has the point 0, 5, because the x value is 0, that means that your y-intercept is 5. So you're going to go +5. See, look how nice that is. And you can move these around. Yours might not look like mine does. Oh, I don't want to do that. Might have to change it. There it is. Okay. As you can see, it is. Oh, nope. Don't want to do that either. Okay. As you can see, I can probably change that. Yeah. Hopefully you didn't do what I did. Okay. As you can tell, it is perpendicular to our first function, and it contains the point 0, 5. So that's it. It's a wonderful tool in order to self-check and make sure that you're doing it correctly. There's one other thing that I want to do, and then that is to be able to graph in standard form. Now we've done a lot of practice with converting from standard form to slope-intercept form, And that is a wonderful skill to have and to be able to identify parts like the parameters of the linear function, which are the slope and the y-intercept. So I'm going to show you how to graph in standard form, but I'm going to show you why I don't like for you to be able to only know how to do it that way. Okay, so let's look. I want to delete everything in here first so I can show you how to do in slope-intercept form. So go delete everything and then go to menu and then go to graph. And then we're going to go down to equation template. Now in equation templates, you've got several different templates. We have only covered the line template. So we've only done linear functions, so we've only done a line. So you're going to go to line. And there's also an equation template for slope-intercept form, a vertical line, which is x equals, and then a line standard form. So we're going to go down to standard form. Now, it has an equation template. Like all you have to do is put in your coefficient for x and y and your constant for c. So we're going to use, this is example, 3x plus 4y equals 6. Now, if you had a negative, like a negative 4y, all you would do is push in a negative, and it would change negative. So let's go ahead and click and see what that is, see what that looks like. It's really nice to be able to visualize your graph so that you can see it. Now you can tell some different parameters from this. The only thing that you can't do, you can't see your slope. You can't see your y-intercept where it is about. The one thing that you could do is look. Let's say I wanted to look at the table in this case. So this is the reason why I don't want you to simply just be able to graph in standard form. I want you to be able to convert from standard form to slope-intercept form, is because when you look at the table and it has a split screen, it's telling me that there's no functions. Well, I put in an equation template, but I did not input a function in there. There is no f of x, so it won't let me look at the table. So it won't let me look at your inputs and outputs. It won't let me see what the y-intercept is, and I don't know at this time. I don't know what the slope is. So I would go ahead and put it. You can, if you just want to see what it looks like, you can graph it in graph it in standard form. But it's really beneficial for you just to go ahead and convert it to slope-intercept form. Now, it also depends on what your question is asking you to do. If the question is asking you to find the x-intercept, well, the x-intercept's at 2, 0. So that's very easy to identify. It just really depends on what the question's asking you to do and what it's asking you to find. So you just have to be really aware of what each problem's asking you to do. So we'll get more into that. I hope this was really helpful. I hope you didn't get frustrated, and I hope that you were able to click when I clicked, so that you were able to be able to graph a linear function in your Ti-Nspire. And I hope that you are comfortable with this. If you're not, please just watch again, and this is going to be available for you. So keep watching. So enjoy.